Hello everyone and welcome to this course on machine learning system design. Machine learning system design is the cornerstone of machine learning interviews at top tech companies, and mastering this ability will not only distinguish you as an engineer but also positions you for higher seniority roles by showcasing your capacity to think holistically about real world systems. This course is designed to transform your problem solving approach. Instead of focusing on memorizing or trivia, we dive into the structured design process behind most frequently asked interview questions at companies like Google, Meta, and Amazon. You will learn to architect end to end machine learning systems from data pipelines to scalable deployment through hands on scenario based exercises. By the end of the course, you will have the confidence to excel in any ML interview, impressing hiring managers with your ability to balance trade offs, optimize for scalability, and articulate high level system strategies. So, let's begin. So, first, let's see the course overview. So, the goal of this course is to prepare you for ML system design interviews and build understanding of how ML systems work in general. So, the key takeaways that you can get from this course is that by the end of this course you should understand core components of ML systems. Then this course will also cover some real world design problems. For example, building recommender systems, feeds for Instagram or Facebook, and cases like ranking the search results. And if you master these, then you can master interviews for FANG and other tech companies. So, first of all, why do we need ML system design and why these are given so much importance in ML engineering interviews, especially for senior roles? So, one is that it's important for interviews. So, this course will help you in cracking some of those interviews. So, in the interviews, they test end to end problem solving skills and they evaluate trade off analysis, like how well you identify different trade-offs like accuracy, latency, cost, scalability. So we will cover all of these in detail, and then it also helps you in real-world relevance. So it helps you build systems that scale, for example, recommendation engines, fraud detection, spam detection, etc. Now let's see what are the key components of ML systems. So there are four major components. One is data pipeline, another is model development, then deployment and serving, and then monitoring and maintenance. So data pipeline consists of collecting the data, preparing your data for training, pre-processing it, and how you store the data. Then once you have the data, then you have model building phase where you do training, validation, optimizing the model, and then you deploy it and expose it as an API, microservices. Then you deal with cloud infra. And once your model is deployed and running, you continuously log data from it so that you may need to retrain and improve your model. You can also do further testing like A/B testing. You roll out different features in your application and test which one is doing better. So these are the major broad categories of a ML system. Now let's see some examples. So we have already seen like recommendation systems. It can be movies on Netflix, it can be products on Amazon website, or any other recommendation like songs or other things. Then search ranking systems. So whenever a user search something, how will you rank those search results? So this is another practical application. Then we have visual understanding systems like segmenting the images and video frames, and these can be helpful in use cases like self-driving cars. Now let's see how we can approach a ML system design problem. So this is a very high level view and we will go into detail of these, and we will also see on some of the practical use cases, then it will be much more clear. So let's see the approach at a high level. So first and foremost is that you should understand the question well. So if somebody says you have to design a feed for Instagram, So it can consists of so many things that you can get lost into it, and you may not be able to come up with a solution within given 45 minutes or 1 hour. So it's very important that you should clarify the question, understand the requirements with the interviewer. Then comes system requirements, like what is the scale, how many users are there, are we expecting millions of users or billions of users, how fast should the model process something. So latency and other requirements you should clarify. And once the requirements are clear, you should define performance metrics, like how you will measure whether your model is doing good or not. So you can, depending on the use case, you can define different performance metrics. And then you have to identify, now your requirements are clear, you understand the problem, you have a performance metrics in place. Now you will identify what are the high level components, what are the key building blocks of the ML system that you want to design. And once you have a high level block diagram, then you should start off thinking of building the model. So for that, first you will need to come up with a strategy for generating training data. And then you have to identify what are the key features that can be important for this use case. For example, you have data, but let's say we have some ID. So that ID will not be impacting any decision. So I'm just giving a vague example, but you understand feature engineering is very important once you have the training data. And then you will think of what kind of a strategy you need, like whether you want to start from scratch or there is already some pre-trained model which you can fine tune for your use case. That will depend on like how much compute or data you have, and that will also depend on other factors. So it can also you can think of like what should be the architecture of your model. So all of these things will come in this last stage, and once you have that, you can go ahead and build that model. So till this point, it's the design part, ML system design. Of course, you can extend it further by deploying and monitoring data from your model, how people are interacting, and then doing A/B testing, and then further refining your model, retraining, and those things. But broadly, at a high level, in the design part, you can think of till building the model. So that's all for this introduction lesson. In the further lessons, we will start looking into some of the ML concepts, and after that, we will start solving some of the real world ML system design problems.